All right, so before we get into our PSPP analysis of an Anova, I did want to go ahead and set up, because a lot of people had questions about this from last week's assignment, on setting up how we would word our populations and how we would word our null hypothesis and our research hypothesis when we're talking about ANOVAs. So I apologize, it is allergy season in full swing here. All right, so here's our example situation that we were working with. We have 3 different groups. These are going to be our 3 different populations. So population number 1 would be worded as students in the classroom that listen to classical music during their quiz, during their exam, during their test. Class 2 would be students who listen to fan favorite, that's what I'm labeling this, music during their test. And then classroom number 3 would be students who listened to ambient music during their test, population 3. So this is how you'd word population 1, 2, and 3. You would designate what their distinguishing factor is. I believe in your textbook, the example that it uses about the jurors, right? It specifies the populations based on what the jurors were told about the defendant prior to the case. If you haven't gotten to your textbook chapter yet, that'll make sense when you get there. But so we word our populations, just like with the t-test, we word our populations based on their distinguishing feature. So how would we word our null hypothesis? Again, keep in mind with our analysis of variance, what we're saying is that there are some by chance factors that are affecting our spread of the scores, but we're proposing that within each group, they're going to have those same by chance factors, and that's all that's really going to make a difference. So our null hypothesis is going to be that these 3 populations have the same mean. That the mean test score in class 1, class 2, and class 3 is the same. That no matter what type of music students were listening to, their mean test score is the same. That the same by chance variables are affecting all students' test scores, no matter which class they're in, because the mean test score is the same. However it is that you want to word it. But the distinguishing feature of a null hypothesis is we're saying everything is the same, right? Nothing to see here, folks. It's all the same. Nothing's different. So our research hypothesis would be the type of music that a student listens to in their classroom is going to impact the test scores. There is going to be a different mean for test scores depending on what type of music the students are listening to. All right. So our research hypothesis is worded in a way that we are proposing that there is going to be something different here. Now, when an ANOVA is calculated, we are using an F test. That's how we label it. So we've done Z tests, we've done T tests, and now we're doing F tests. So that is the label for an ANOVA. So we know how to word our populations. We know how to word our null hypothesis and our research hypothesis. We know that K stands for number of groups. We know that F is the abbreviation for the Anova test. We have calculated our grand mean. So we are good to go in terms of plugging this stuff into PSPP and seeing how this is actually going to be done. So that's going to be the next video.